Hello, hello, Shagath Unknown here. Welcome to another Rust coding stream here on the 31st of October 2022, local time 1732. Last time we wrapped up the main functionality of the game here, which I'm just kind of loosely demoing real quick. We got our stairs, that's been in for a little bit. We got our items here. We should have some equipment and stuff if I find any, although it does become, oh, okay, never mind. So we have a fireball scroll, we have the shield and the dagger. So we can equip both of those. Both of those are a little less common until we start getting further down. But yeah, that's pretty good. Not a bad haul there. Get us a health potion. And yeah, it turns out that I still wasn't able to find a way to, like, I don't know if fix is the word, but, well, yeah, fix, but in a very specific meaning, as in set the size of the window when I launch the app. So, I want it to still be the same size console, but I want it to, be stretched out a bit so I can see a bit better. But unfortunately, I didn't find a way to do that yet. So I still have to stretch this thing out every time I open it so I can actually see it. But yeah, it's not too bad. Running. Soul running. Alright. I need to bop these dudes. And... oh, we already found the stairs. Why am I over here risking life and limb when I could go to the next floor? No. Bop that man. Looks like I took down a couple of them. So we actually have a tower shield and stuff as well. So it's daggers, but we also have like swords and tower shields and stuff as we get further down. So that also helps us be a little bit more survivable. And the enemies will be more and more common as we go down, just like the items. But that's really about it for the functionality here. Not much more to say. So what are we going to do today? Well, today we're going to be doing, what are called like stretch goals in this case. And they're basically going to be a few fun things that we can implement that are just going to make the game look nicer for the most part, but also add a little bit more functionality that's kind of not required, but can be fun. One of them is going to be the hunger clock. So first thing we're going to do is just nicer looking walls. Very simple, very easy. And then after that, we're going to be doing, what is next? Blood stains and then particle effects. And then after that, we're going to be doing the hunger clock. So I'm going to try and get through all 4 of those, which means if I'm going to actually succeed at that, hey, there we got the sword I was looking for, the long sword. If I'm going to succeed at getting through all 4 of them, I need to stop playing and actually get to the tutorial. But it's fun. I was also curious if we get the tower shield, but doesn't look like it. We're getting all kinds of long swords now. So they do appear, I don't remember what floor they start appearing, but they become more common as we go down. And if we got the tower shield, I don't know if I've actually really played with it yet, so maybe I do want to keep going just a little bit longer to see if we can find one. That's not it. Because it would be nice to find one. Let's see, what's health? D, J. Nice. Yeah, it would be nice to find one and actually see how defensive that makes me. Let's just go down another. That's it. Sweet. Alright, so we have a tower shield, and it got put onto J. So we'll equip that. Fireball scrolls are my favorite. Say one shot. So if he hits me, he's unable to hurt me. So I'm immortal, I think, against everyone now. Cool. What you'd probably want to do is you'd also want to make the damage a little bit more random. Oh, I think my inventory is full now. No, not quite. Maybe I hit the button on the wrong tile. Alrighty, so yeah, that's that. That's a little overview of what we got. And, oh wait, something hit me? No, I think we're good. Like I could probably just run around and do whatever I want. I'm immortal now. So some of the numbers are not really as fine-tuned as you might want them to be if you were making a real game you were going to release. You'd probably want to fine-tune the numbers a bit more. There's nothing wrong with being immortal from some things, but we're immortal from everything now. You probably wouldn't want to make that your game that you're, marketing and selling or something. So we're already on depth 7, and we can't be beaten anymore. So that's it. So a little bit of a long thing there. Man, I had a hard time getting started today. I laid down for a bit. I got back up. I reboot the machine, and I always like to wait just a moment before I log in, enter the password thing. And I'm looking at my phone. I look up and I've blue screened, which almost never happens. So I was like, that's concerning, I guess. It reboots again, and then I log in and nothing seems wrong. Everything seems fine. I get all my stuff launched up and ready to go. I open OBS and I have no camera. I had to fight with that for a few minutes. It's been a weird one. I was like, we're just gonna go no camera. I mean, it's not that critical, but it's there. But obviously I got it working. But that was just frustrating time getting started. Alrighty, so Section 2, Stretch Goals. I've been enjoying writing this tutorial and people are using it. Thank you. So I decided to keep adding content. Section 2 is more of a smorgasbord of content than a structured tutorial. I'll keep adding content as we try to build a great roguelike as a community. And then please feel free to contact Roberticus on Twitter. If you have ideas for questions or improvements or whatever, there's Patreon spam. We got that. We could support them on Patreon. There's a link on here. You can go to the page yourself if you want to do that. Alrighty. So, nice walls with bit sets. This was going to be really short, but just look, make the game look a little nicer. So that's kind of the point of these stretch goals. That's why we're going to try to do 4 of them here today. Hunger Clock's going to be the longest one. So far, we've used a very traditional rendering style for the map. Hash symbols for walls, periods for floors. It looks pretty nice, but games like Dwarf Fortress do a lovely job of using code page 437's line drawing characters to make the walls of the dungeon look smooth. This short chapter will show how to use a bit mask to calculate appropriate walls and render them appropriately. As usual, we'll start with our previous code from the end of section 1. My guess is that we're going to bit mask the entire map and then look at actually it says counting neighbors. Look at the neighbors of each tile to determine what kind of wall we draw. Basically, are we drawing an L, like a corner or something? What are we drawing? So counting neighbors to build our bit set. We have a decent map rendering system in map.rs, specifically the function draw map. If you find the section that matches tile by type, we can start by extending the wall section. So we have the tile type wall, and we're going to be changing that a little bit. Okay. Everything on the screen there was basically the code, by the way. So it's going to be really short for this section. So map.rs, and it's draw map, and tile type wall. So we have the glyph. That's already... Okay, so we're changing this. So it's going to be n star map xy. And instead of this, it's going to be wall glyph, which we don't have yet. And then the RGB is going to stay the same. So we need to make wall glyph. So let's go ahead and work on that. It's going to take map like that, and X is going to be an I30. Something weird, I don't know. And it's returning a U16, but we actually want it to be an RLTK font char type. Okay. And now, what are we going to do in here? If X is less than 1, or X is greater than map.width -2, or Y is less than 1, or Y is greater than the map.height -2 as I32. And we're going to return 35. So that is a border 35. That's going to be the border of the map, basically, right? Well, no, we're saying if we're out of bounds, but I don't know why we would be out of bounds. So I'm not sure what 35 is going to map to. So we'll see where that goes. Let mute mask u8 equals 0. So maybe we're not going to be doing a mask over the entire... Well, actually, the map already kind of is an entire data structure. What was the map again? What did it actually contain? Yeah, it's got like vectors of all the tiles and everything. So maybe that's all we need. Alrighty. So we don't need to build up a separate mask, I wouldn't imagine, but we'll see how this works. If is revealed and wall map x y minus 1 mask plus equal 1. Do we have that function? Yeah, we do not have that function, so we're gonna have to do it as well. That's okay. And I'm gonna basically put this 4 times. So it's gonna be x y minus 1. It's gonna be x plus equal... Oh no, oops, I'm looking at the wrong thing. I was like, wait a minute, that's not right. Not there. There's like 2 things side by side that are throwing me off. X, y minus 1. So now we're gonna do the same for x's, right? X minus 1, x plus 1. And we're gonna say mask plus equal 1, plus equal 2, plus equal 4, and plus equal 8. Now, knowing that this is a mask, I'm going to go ahead and just take my stab at what's going on here. We actually are building up a mask for the tile that we're checking, but it's a mask of the neighbors. And it's the no diagonals, just the cardinal direction neighbors. And we're saying, so x stays the same, but we're gonna do y minus 1 and y plus 1, so we're gonna do the verticals. Then we're gonna do the same with the horizontals. And what we do is we start it at 0, and then we add 1 to represent, if we're doing minus 1, I guess it's gonna be up, right? So if this bit is set, the bit that corresponds to 1, then we know there's a neighbor above. If the bit that corresponds to 2, which will be the second bit, is set, then we know that there's a tile below. If the bit corresponding to 4 and the bit corresponding to 8 are set, then left and right neighbors exist, respectively. So what we're going to be doing is basically not bit shifting, because looking ahead, we're doing a match, but it's essentially the same as kind of bit shifting and just checking a bunch of different combinations of this. But the thing is, when you're setting these values, we know there's only so many possible values it can be. So there can be 1. Like look at it this way. If only this hits, you can have a 1. If these 2 hit, you could have 3 as your value. Or if the first and the third hit, you could have 5 as your value, right? There's only so many different possible values we can have from this, and this tells us all the possible configurations of tiles. So rather than actually bit shifting and checking things like that, we just check the actual combined values that we end up with. So this is how we end up with a big beefy segment like this. It's going to be that. Do I want to type this? I kind of don't, because it's a big old match here. But if I just do it and get it over with, it won't be that bad. But we'll see. 186. Wall only to the north. So wall only to the south. So like, how do we get 3? wall to the north and south. So like we get one, obviously if this one matches, or if only this conditional trips. We get 2 if only this one trips. We get 3 if both of them trip. Right? And then we get 1 and 4 gets us 5. 2 and 4 get us 6. But we can't get, no, we can get, yeah, we can get 7. We can go up to 8. Okay. Yeah, this, oh, wait, yeah, of course. We're only setting the, I'm sorry. We're only setting the first 4 bits, so that's basically just getting us up to 15. I know I didn't think about it like there, like that at first. So that's not bad. So it's going to be 5. I think that's 15. But yeah, what I'm trying to say still stands. It's just harder when you're looking at the conditionals to see how it maps out. But again, if you think of these as bits, it's almost easier if you were actually setting bits, because we're just talking about set the first bit, the second bit, the third bit, and the fourth bit. And at that point, if you don't understand, you need to go look at how like the binary representations of these numbers work. And then you can see how all 4 of these smush together. And if they're all 4 set, that gets you 1, 1, 1, 1, which gets you 15. Alrighty, so then what are we going to do here? 205 for 4. 5 is what? 188. 6 is 187. 7 is 185. 8 is 205. So we see the idea here, right? Now, I'm going to go ahead and actually copy this match so I don't make any mistakes and to get the comments for free. And then we'll break down just all the different possibilities here. Yeah, I had a feeling that was going to happen with the auto format because you don't really need to put the brackets there. So in the case that we have 0, what we're doing, we're mapping it to these numbers, but these numbers are actually going to be this font char type thing that maps that RL to the, what's it called again? The code page 437. They actually map to that code page 437 and they get us the type of wall that we want. So I'm not going to go over every single one here, but you can kind of see, actually we got one of the symbols here. In the case that we do have a wall on all sides, we get like this plus thing going on. So it's pretty cool looking. And then for other ones, like if we have a wall to the south and the east, we're probably going to build like an L or something. So that's kind of what we're getting here. And you could look up the code page 437, look at what these numbers are and see exactly what we're going to get. So how you design this is literally looking up the code the code page 437 and figuring out what symbols you want. That's all. And again, we're just building out here a combination of 4 different bits to decide what, basically to decide which symbol we're going to use. So again, you could do stuff with like, checking individual bits, but that's not necessary because in this case, there are so few values, it's easier to just check this way rather than going over the individual bits. So the last thing we're going to need is the is revealed and wall, because it's complaining that we don't have that, and that one's really tiny. So basically it's going to take the map and it's going to take a couple I32s and give us a bool, and it's just going to get the index with X and Y. And then from that, we're going to say map.tiles IDX equal tile type wall and map.revealed tiles IDX, which is already a Boolean, so we don't have to do any more checks on that. So if it's a wall and it's revealed, kind of like the name of the function suggests. So let's go ahead and run that. Oh, we have something being angry here. Expected I30. Okay, so the one thing we changed in draw map. The glyph, this glyph in here. No, this one. This wall glyph. So glyph is saying U16. This returns us this code page 437. That's the only thing I see. Let me get the compiler. Let me get its opinion on this. Why did that pop up? That wasn't a problem before. Gonna hold undo for a bit. Literally undo everything just to see the change here. He didn't touch that line. But that line is happy right now. So that's curious, is it not? We cargo build right now. We're fine. So we need to break down what's changing and figure out why that's happening. That's not mentioned in the tutorial. All right, that's everything. I save, and we're getting that complaint again. So my issue is not so much about, oh, how do we fix this? We can just cast it. My issue is more about what is actually causing that to happen. So map width is a U size. X is an I32. Is map width? Yeah, no, I guess it should be a U size. I'm gonna check their source real quick and see if I have some tiny discrepancy. They are casting it. Why was I not? Why was I not casting this before? But it wasn't angry. That's rather curious. I feel like I'd like to look more into that later, not now. So let's go ahead and run this now and see what's going on. Hopefully things look a lot nicer. Yeah, I would say the walls look a bit better. We got the chunky walls there, okay. It's very traditional roguelike. I mean, Dwarf Fortress being brought in as an example makes sense here. Like to find, oh, and that's the border of the map, which we're drawing with the pound signs there. All right, yeah, I don't think we need to see any more. Like, that's what we expect. Simple enough, right? What's cool is how you see that one... When we only see a single tile, we get that circle, which is not bad. That's what we kind of expect. See that there? That's an isolated wall. And then as we find more, it kind of changes symbol a little bit. I do find that interesting, but yeah, it's good. It's good. I'm happy with this. Alrighty. So that's it for this section. We have a little bit more to read because I did skip through it, but that's it for this section. So we're going to break through the function of what's going on here. I kind of already did that myself, but if we're at the map bounds, we aren't going to risk stepping outside of them, so we return a pound symbol, ASCII 35. Now we create an 8-bit unsigned int to act as our bit mask. We're interested in setting individual bits and only need 4 of them, so an 8-bit number is perfect. Next, we check each of the 4 directions and add to the mask. We're adding numbers corresponding to each of the first 4 bits in binary, so 1, 2, 4, and 8. This means that our final number will store whether or not we have each of the 4 possible neighbors. For example, a value of 3 means that we have neighbors to the north and south. Then we match on the resulting mask bit and return the appropriate line drawing character from the code page 437 character set. The function in turn calls is revealed in wall, so we'll write that too. It's very simple. Yeah, and we just did that. You literally just get the index and then ask if it's a wall and if it's revealed. And then if both are true, boom, you're good. Then we run and we get a nicer set of walls. I don't know why that casting error started coming up though, and I'm very curious to look into that later. Number 2. This one's also going to be short, but I'm taking too long. Alrighty. So, bloodstains. Our character lives the life of a murder hobo, looting and slaying at will, so it only makes sense that the pristine dungeon will start to resemble a charnel house. It also gives us a bridge into a future chapter, in which we'll start to add some particle and visual effects in ASCII CP437 to the game. Storing the blood. Tiles either have blood or they don't, so it makes sense to attach them to the map as a set. So at the top of map, we'll include a new storage type, a hash set. So let's go to map.rs and we'll pull that. Actually, we don't need to pull that in. We'll have it auto pull in. So in the map definition, we'll include a hash set of usize to represent the indices. That's going to be the last thing. Mad. Boom. Alrighty. And then in the map generator, we'll initialize it. After that, we'll say bloodstains. And it's just a hash set new. It's empty. Whoops. And this one is also mad because I still maintain it for no reason. There we are. This one would be cool to actually use for just a minute, just to see all the walls and stuff with the other map. Might do it at some point. But we're actually going to be doing different map generation algorithms, so it's probably I'm just going to tear this down. Not today, though. Not yet. So rendering the blood. We'll indicate a blood stain by changing a tile background to dark red. We don't want to be too in your face with the effect, and we don't want to hide the tile content, so that should be sufficient. We'll also not show blood that isn't in visual range to keep it understated. In map.rs, the render section will now look like this. Alright, so is this in if map.revealed tiles? There it is. So I guess the yeah, that's good. So down here, I don't think we're going to touch it at first. Oh no, we are going to do so we're going to do the glyph, we're going to do the foreground, and let mute bg equal rgb from f32. It's going to be 0 dot 0 dot 0 dot. And now we're going to use that down here before this line. So if map.bloodstains.contains index, then bg equal rgb from f32 0.75, and then these are going to be 0 dot and whoops and 0 dot. I don't really like I don't like the dot and then nothing. That format kind of bothers me. So then if map.visible tiles, blah, 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 we do the grayscale. We do bg equal rgb from f32. Let's just copy this. And it's going to be another 0 dot. I don't think we need to initialize it up here. Actually, we kind of do. Because these are all in conditionals. So then we set the blood. Could almost do this after, right? No, no, I see why. Yeah, yeah. Never mind. All right, don't show stains out of visual range. And then instead of this, we do BG. That's it for actually showing the blood stains. But now we have to make blood. So as the tutorial says, Warhammer reference, blood for the blood god. Now we need to add blood to the scene. We'll mark a tile as bloody whenever someone takes damage in it. We'll adjust the damage system in damagesystem.rs to set the blood stain. Righty, where is that one? Right there. And we're going to go to... Oh, it's right here. Good. So, stats, damage. We're going to need a couple more things. I'm going to be a little lazy on this, but we'll break down everything that we actually have here. But see, we currently take 2 things in the damage system. Combat stats and suffer damage. Now we're taking combat stats, suffer damage, position, map, and entities. So it got a little bit beefier here. So we'll say position. Whoa. Put that in a bad spot. And we'll pull those things in so we can use them. Now, what are we going to do with them? Well, for entity, mute stats, and damage, and entities, and mute stats, damage, join. Stats.hp minus equal damage melt. Let position equal positions.get entity. So we're getting the position of where we're at, and then we're going to use that to set the tile, right? Just like that. Map.bloodstains, insert IDX. So that's it, basically. Damage.clear. Boom. So now if we cargo run, we'll actually get some blood stains. So what are we doing here? Why did we pull in what we pulled in? Well, we get all the entities. So then what we're doing basically is... I question one thing. Is there a case where something would not have a position but be taking damage? I wonder why we wouldn't loop through positions rather than entities. But basically what we're doing is saying, get me the position associated with the entity taking damage. Yeah, it's the same entity that we're looking at here. Interesting. Yeah, I feel like we could just add position in here as a component. But I guess there could be a case where something takes damage and has no position. So we'll leave that one to the side. Just a thought. And then, you know, in the case that we did get a component there, a position component, we take that position and use it to set the index in the bloodstains hash set. And the way that works is like it's either there or it's not, right? So it is just a hash set of U sizes. So basically, it can only contain one. A set can only contain one of something. A vector, you could put a vector of U sizes or whatever. You could put the number 47 in there 47 times. A hash set, being a set, can only take one copy of 47. So it's either in there or it's not. It's that uniqueness that makes it a set. So that's useful for this case, where it's either there's a bloodstain there or not. We begin new game. And we scour the dungeon for an enemy. Yes. Confusion scroll. This place will get bloody quickly, though. because it's just taking damage, not dying. Okay, so I find all the items and no enemies. Oh, there we have a interesting, completely single wall there. Interesting to see that one being formulated. Yeah, see, I'm taking damage. Haha, there we go. And then if we walk away, we don't see the blood anymore. Okay, that's all. That's all we needed a demo to make sure that's working. Simple enough. All right, that's 2 sections down. A little bit slower than anticipated initially, but got sidetracked by a couple things there. But it's going. I mean, we're only 35 minutes in, 36 really. Alrighty, let's go. I mean, is there really anything else to read here? I mean, the code was simple enough. We set a background. If there's a blood stain, set it red, but then just as a sanity check, if it's not in view, set it back to the black. And then we just broke down what happens here. We get a position for the thing taking damage, and if it does, like if we did get a position, then we set that value in the hash set for the index to say, hey, there's blood there now. That's it. Nothing to it, right? Okay. So next is going to be the particle effects. This one's going to be a bit longer. Hopefully it doesn't take too long because hunger clock, it's actually shorter. Okay. So this will be longer than the hunger clock. So again, I'm going to try and do both of them. And then these magic mapping and Rex paint and stuff will take a little bit longer. So there'll be one session probably. Let's double check. Magic mapping's not bad. Rex paint's not bad. Perhaps a little bit longer. So yeah, we'll see how this goes. So particle effects in ASCII. There's no real visual feedback to your actions. You hit something and it either goes away or it doesn't. Well, there is visual feedback, but in the log, not in the game. Bloodstains give a good impression of what previously happened in a location, but it would be nice to give some sort of instant reaction to your actions. These need to be fast, non-blocking, so you don't have to wait for the animation to finish to keep playing, and not too intrusive. Particles are a good fit for this, so we'll implement a simple ASCII CP437 particle system. So we're actually doing it with the ECS. That's interesting. As usual, we'll start out by thinking about what a particle is. Typically it has a position, something to render, and a lifetime, so it goes away. We've already written 2 out of 3 of those, so let's go ahead and create particle lifetime component. Components.rs, we'll do this. Now again, I'm going to be a little lazy on making the components at this point because it's boilerplate. We've done it many, many times. It's not really teaching us anything new at this point. That's kind of my criteria for a little bit of copy pasta. We don't copy new code. We don't copy things that we're learning. We copy things that are just boilerplate that we've done many times. So what that does mean is we need to register that here in main, right? Whoops, wrong thing. And this is, what is it, particle lifetime. And then we need to go to the save load. Where is that at? In case any particles are somehow still alive, I guess we need to save and load them. I'm not sure I understand that. I don't understand why you'd still have a... I mean, maybe there's an infinite particle for some reason. Because we can use it for other things, right? Maybe we use fire with a particle or something cool. I don't know. Alright, so we register it in main and save load system. And then we're going to group the particle code together. So we'll make a new file called particlesystem.rs. It won't be a regular system because we need access to the RLTK context object, but it will have to provide services to other systems. The first thing to support is making particles vanish after their lifetime. So we start with the following. Let's head on over there and make it. New file. What's it called? Particle system.rs. Now, my strategy on making this is always to come here into main first and foremost. Mod particle system. I'm not going to use anything from it yet, but Well, we are gonna. Okay, no, it doesn't look like we need to do that. Okay. So I'm not going to use anything from it, but what this now allows me to do is get feedback in this file, because now the file is actually being pulled in somewhere in main. It recognizes, oh, okay, I need to do linting and stuff for this file. So unfortunately, it doesn't do that unless it doesn't seem to do that unless it can find main or can be tied back to main. That's what I was discovering before. So use specs, prelude, everything. Use super RLTK particle lifetime. Alrighty, so we're going to make a public function called call dead particles. And it takes ECS, mute world, CTX, and RLTK. And we're going to get the dead particles. So what we're probably going to do, my guess, based on how we've done things before in this ECS, is we're going to do a loop through all the particles and check their lifetime, add them to the vector if they should be deleted, and then actually delete them. Let's see that happen, because I almost said a phrase I like to use, but it's not the most appropriate phrase. I like to keep the coding streams a little more professional. I was going to bet one of my body parts that's probably what's going to happen. I caught myself, though. I don't like to talk that way on these streams. So we're going to join them up. Join up entities and particles and do probably exactly what I said. Particle dot lifetime milliseconds minus equals CTX dot frame time ms. If particle dot lifetime ms is less than 0.0, dead particles dot push entity. So one thing that I'm a little interested about on this is that we're actually having the lifetime be updated in the system that deletes particles, rather than separating the two, having a system or having a function that manages the state of the particle, the lifetime, and then having this one simply do the check. But it's pretty basic. ECS.delete entity. Again, I always question why we don't bulk delete. But it's fine, it still works. I mean, it's probably doing about the same code under the hood anyway. But there might be some optimizations when, you know, sending in like a slice, a big vector or something. That's it. That's exactly what I said was going to happen, though. We get all our particles, we get all our entities, we loop through the join of those, and the one thing that caught me off guard was this. We take the context, and it gives us how long the frame took, frame time milliseconds, and we subtract that from the lifetime of the particle. If the particle is expired, if its current lifetime is less than 0, then we add it to the list of dead particles, and then we delete the dead particles. Nothing to it, right? Pretty straightforward. So in main, what are we going to do? The render loop, ctx.cls, it's right here. So particle system call dead particles with nmute self.ecs and ctx. Just like that. So now we have the system, but nothing's actually making particles, so we probably want to make some particles. So let's extend particle system.rs to offer a builder system. You obtain a particle builder and add requests to it, and then create your particles as a batch together. We'll offer the particle system as a resource so it's available anywhere. This avoids having to add much intrusive code into each system and lets us handle the actual particle spawning as a single fast batch. I find that interesting, actually. I've done plenty of builder patterns, but I've never done a batch builder, so this will be fun. It's probably not going to be very difficult, but I was going to say it's probably going to be like a vector, and I actually see that it is a vector. Probably literally just build out a list of the things we want to make and then actually make them. So that's cool. So our basic particle builder looks like this. We haven't done anything to actually add any particles, but this provides the requester service. So in particle system, let's go ahead and make that. I like to make my structs nearer to the top. Struct particle request x I32. So that's the location, right? X and Y. Foreground is the color. And background and glyph. RLTK, font, char type. We've seen all this before. Lifetime, F32. Not Rust lifetimes, but a different kind of lifetime. And this we need to pull in the RGB. Alrighty, so that's happy now. And we're going to do pubstruct particle builder. And that's just going to be requests is a vec of particle request. If I could type, but we got the autocomplete. That's what autocomplete's for. You don't have to know how to type anymore, right? It's 2022. Now we're going to impl particle builder. So we're not actually touching request. And allow new without default. So interesting. It's a clippy thing, but we're going to explore this before I add that. So we're making a new particle builder. Particle builder. And request is just a new vec. Whoops. Alrighty. What it might be saying is new without default, as in you made a new function. And this is idiomatic Rust, so Clippy can easily find this. It's like you made a new function, but there are no defaults. So the user might want to say, give me a default particle builder. I've never seen that lint show up before, but I'm going to look for it real quick. This function doesn't need a mutable reference. Yeah, there's probably a few things like that in there. You can get away with a little bit more in Rust than you sometimes think. But this one is actually part of the macro, which we're not even going to get into that right now. Clippy, I'm looking for... Sometimes, yeah, function new is never used. I'm assuming that's what it is. It's just like an idiomatic thing. Like, people might want to make a default, and you don't have that option. But it's fine. We can add the thing, we can ignore it. Okay, what else? Lifetime. Oops. Why is that mad? Oh, glyph. That's what I was missing. Got it. Alrighty. So we're gonna make this request now, which just gets added to the builder. Is it? It's not returning anything. No. Okay. So you can't like chain them, but it's not that bad. All right. So self.requests.push. It's literally going to be particle request with all of these things that are already appropriately named. And I screwed that up. We got to do it the slower way now. Not a big deal. Boom. Good naming there, so we save some time. What's this? Alrighty. That's about it for the requester and all that. So quick breakdown, it's not difficult, but quick breakdown. We're making something called a request, which has all the info we need for a particle. Make a builder struct, which is just a vector of those requests. We make a new function so we can actually make a builder. And then we make the requests. Each request is just all the stuff that we need, and it gets pushed into the vector. We're not actually creating them yet. So we'll have to get to that in a minute. But in main, we're going to actually make this stuff a resource now. So we're going to come all the way down here, and it's gs.ecs.insert. So we'll probably just go ahead and do it. Is there any particular place to do it? Probably not. Particle system, particle builder, new. Okay, there it is. So basically we've added this. Now anywhere in our code we can say get me particle builder, and that actually gives us the builder, so we can push stuff into it, and then I guess they'll be created. All the requests will be created every frame, right? Every time we go through the game loop. So then in particle system.rs, we'll build an actual system to spawn particles. And this is going to be a real like ECS system, spec system rather. So it's going to be hub struct. I'm breaking what I like to do, but we're going to separate the code a little bit because this is going to be right next to the impl. Particle spawn system. And this is an empty struct. It's here literally just for the purpose of a system. Impl a system a. Get our lifetimes in there for particle spawn system. And we're going to do the allow type complexity because it's going to be an ugly one. It's not the worst. We have way worse. So system data equals, and I'm going to do the boilerplate stuff here because why not? This will get us most of the way. I'm going to delete that. This will get us most of the way there. And I need to add that bad boy. Cool. Now if I want to be a little bit lazy, I will have these auto import, position and renderable. We'll just do it here. All right, now everything's going back to normal a bit. Okay. That's not formatting. If we were to, what is it? If we're to take a look here, the actual line is really short. But with the, oh no, it's underlining. I thought it was crossing it out when I moused over it. When we actually have the type hints or whatever they're called being brought in, we can see the line looks a lot longer than it really is. So sometimes I do want those to format based on the hints, but it doesn't happen. That's the one minor issue that I have, but yeah, it's not a big deal to me. Alrighty, for new particle in particle builder .requests.iter. I should actually break down what we're pulling in first. We're getting all the entities. We're getting writable access to position, renderable, particle lifetime, and particle builder. Now note, write expect is a resource. So particle builder, we're getting that resource we just set up, which is the new builder. All right, simple enough, I hope. Let p equal entity, and then we're like joining up on, we're not joining on anything actually. We're just ripping all those apart, and we're just iterating through all the requests of the builder. Entities dot create. So what does this get us? Is this a builder? Oh no, it just makes a new, oh right, it's just a new entity, but nothing's attached to it. Right, it's been so long since we've done anything like that. We're doing it a little bit different. We're getting the entity, we're not doing a dot with and everything. We're getting the entity, and then we're going to attach a couple things to it like this. It looks like positions dot insert p position. It's going to be new particle dot x, new particle dot y dot expect. And what do we expect? Unable to insert position. Whoops. No, I do that kind of as a joke. Insert. It's actually a typo, but we know what it's supposed to be. I'm going to put that there. And I'm going to put another one of these. Go ahead and put the expect unable to insert lifetime. We're going to put one more dot expect. I don't know what it's going to go on yet, but I have to scroll this back and forth on the tutorial. So I want to get these in so I don't have to keep scrolling anymore, hopefully. Unable to insert renderable. Wouldn't it be funny if I made a typo after making that joke? Yeah, I'm still going to have to scroll a bit. That middle line is a bit lengthy. Insert the position with the X and Y of the new particle. Simple enough from the request. Renderables dot insert p renderable. And this is where all the real beefiness is going to be. New. Oh, they're in a different order. That's not confusing, is it? New particle dot glyph. New particle dot fg. New particle dot bg. New particle dot. Oh, we don't have render order. It's just 0. Okay. Yeah, I was like, we didn't set that. But I don't remember how we set up render order. I'd have to go check the code again. And that's all for that. Now, lastly, for the position here. Or no, not position for, this is part, oh no. Double click. Particles dot insert. And it's not going to be a position. It's going to be particle lifetime with new particle lifetime. Unable to insert lifetime if we fail it. Okay. Then finally, particle builder dot requests. Ooh. Dot clear. Just like that. All right. So what we're doing, we get the entities. Again, writable access to position, renderable, and particle lifetime, and writable access to the particle builder resource. We loop through all the requests, and for each one, we make a new entity. We give it the position as defined in our request, which we're calling new particle. We give it the renderable as basically defined in our request with the glyph, foreground and background. And then we give it the lifetime as defined once again in our request. And then we just clear out that vector because we've already made the particles, so we don't want to keep requesting the same particle. So we clear it out. And that's going to run like once every frame, I guess. So we'll continuously be making particles as we need them. All right, so very simple service. It iterates the requests and creates an entity for each particle with the component parameters from the request. Then it clears the builder list. The last step is to add it to the system schedule in main.rs. And allow me to be a little bit lazy here and just copy pasta this. Because it's going to be let mute particles. We literally just get the particle system and run now. We've done this before. Again, that's not really anything. We're not learning anything from that at this point. And it makes sure that we keep parity between the two. So there we are. All right. So we've made it depend upon likely particle spawners. We'll have to be a little careful to avoid accidentally making it concurrent with anything that might add to it. Actually spawning some particles for combat. Let's start by spawning a particle whenever someone attacks. Open up melee combat system. We'll add particle builder to the list of requested resources for the system. Okay, so we'll take care of that. And then a write expect to be able to write the resource. So this is going to be another one of those. I'm just going to copy that to make it a little bit quicker and easier. And then we'll do the code separate. We'll do the code ourselves. Save some time, right? So melee system here. It is particle system particle builder. It's like that. And in this melee combat system, we're going to get that system data. Basically, we're just adding that particle builder resource in there. But now, of course, things are mad because we have an extra thing in the tuple that we're not... oh, no, wait. Position? Oh, we do need position. We didn't... Ah, they didn't mention that. I put what you said we need. But yeah, now we're like out of sync because we are pulling in more things in system data than we're actually ripping out and using. So let's fix that. All right, now I have a couple unused. Good. And then we're going to add the request. So where does that go? Well, it doesn't tell me. So it's right. Okay, it's right before let damage. I was going to say let's deduce it, but no, it's right before let damage. So it's let damage equal I32 max. I was going to say which let damage. Oh no, that's if, not let. My bad. Excuse me. All right, so here let position equal positions dot get once melee dot target. So we're putting the particle on the target, the thing that's being hit. If let sum position equal position, and this is going to be particle builder dot request. It's going to be position dot x, position dot y, RLTK RGB named RLTK orange. That's good enough. And then RLTK RGB named. And then what is this one going to be? Black. And then the glyph is going to be RLTK to CP437. And it's going to be... What? Hold on a second. And then there's going to be 200.0. What is that? That's a character, but it's not. It's two exclamation marks, but it's. I don't know that. Okay, that's a character I'm not familiar with. Well, there we are. I copy paste that character because I don't know how to type that character, but it's two exclamation marks. So then let damage I32 max. Are they just showing that for? Yeah, I don't think anything changed. I was like, why would anything change? Okay, easy enough. We get the position of the thing that's being attacked. And if there is one, we do a builder with that position as the location of the particle and the orange and black. And we give it that exclamation mark thing. Cool. So the cargo run now, we'll see a relatively subtle thing. So let's check it out. The exact wording. If you cargo run now, you'll see a relatively subtle particle feedback to show that melee combat has occurred. It definitely helps with the feel of the gameplay and is sufficiently non-intrusive that we aren't making our other systems too confusing. Alrighty. Yeah, okay. It's not bad. I accept the results of the particle builder system, or the particle, whatever. What do we call it? Particle system. That's all. Okay. Now we're going to do a little bit more. We're also going to add effects to item use. It'd be great to add similar effects to item use, so let's do it. An inventory system will expand the item use system introduction to include the particle builder. And you know I'm not typing that. You know I'm not going to go through line by line and figure out exactly. It looks like particle builder and position probably, but sometimes they put them in weird orders, I've noticed. So we're going to go to the inventory. And we're going to look for item use. And we're basically just going to copy through all of this, because I think this is everything I copied. Oh, whoops. I didn't deactivate the browser. Okay, we're good. 1 second. Alrighty. Yeah, so I mean, you didn't miss anything. I literally just pasted that over the existing piece of the inventory system. But we'll actually do a Control Z. In backpack, yeah, I just added those other couple. But there's so many things going on here. I didn't want to do that myself. Not fun. We'll get the builder. That's what we need. Okay, and then what? We'll start by showing a heart when you drink a healing potion. So in the healing section, where is the healing section? Targeting, blah, blah, blah. If it heals, apply the healing. So stats.health. I say health. My brain, I convert HP into the word health. Stats.health. Cool. Use the potion, used item equal true. Apparently not. Hold on. The used item stuff got a little weird before. What's weird though is that I've used healing potions and they're not infinite. They're being used somehow. I think the reason is because we're setting it to false, and then later we set it to true if we get in here and properly use the item. I'm gonna make this, just like take this down as a note. I'm gonna fix this a little bit. Some of that got a little weird before when we added that. I do remember that being a thing that popped up and never got into full parity with the tutorial, I guess. So we'll address that later. It's not going to be difficult. It's going to be something like this. Yeah, we set used item to false, and then if it actually gets used, then we set it to true. So whatever, that's not part of this right now. So I'll fix that on the side. After the entity, player entity thing, let position equal positions dot get target. And we're going to say if let sum position equal position particle builder dot request position dot x position dot y rltk RGB named RLTK green. Probably going to be black, black background. And then I don't know how to type that, so we're just going to copy. Let's copy the last two here. I don't know how to type a heart. Actually, is it like, hold on. Yeah, I did. I did type it. It's, you can hold Alt and press 3. I was like, wait a minute, I think I do. That's 2. So 2 is a happy face, 1 is another face, 4, 5, 6. So yeah, 3, 4, 5, and 6 are all the card face things. I was like, wait a minute, no, I've done this before, isn't it? I got it the first try too, that's awesome. Okay. So, happy with that. So we're gonna copy this because we're gonna be doing it a couple times. So it says, we'll show a heart when you drink a healing potion. We can do a similar effect for confusion with a magenta question mark. So in the confusion section, we're probably going to do it right after this. Game log entries, push. Do it right here. But instead of target, we get mob. And then magenta, black, oh, sorry, whatever. And just do a question mark. We should also use a particle to indicate that damage was inflicted in the damage section of the system. You use blank on blank inflicting HP. Item damages right here, okay. So we just put it right after that. So it's going to be the same thing. Here it's going to be mob again. It's going to be red. And it's going to be that double exclamation mark thing again, which I don't know how to type that. We could just keep pressing different alt things until we find it. 11, 12, 13, 14, 15, 16, 17, 18, 19. It's 19, okay. Alt 19. So the way that works, by the way, you hold Alt, you press numpad, I should specify. I don't think it works on... Oh, yeah, don't do that. I don't know what I just did. Does that switch? Oh, it does. Interesting. I never knew that. Damage system. Where was I at now? Not damage system. Item inventory system. So yeah, it has to be numpad. You hold Alt and you press 1, 9 on the numpad. You let go. You get that. If you don't know that, you can do Alt 0, 2, 3, 4. No. Alt 0, 2, 2, 2. 0, 2, 4, 3. RR. Thor, the actual name of Thor, as people say. I've typed that way too many times. T0253 R Thor, another Norse deity. Alrighty. I don't remember how to type Odin. It's been too long. But just things. I used to type those a lot if you can't tell. I still kind of remember that. Alrighty. In the damage section, we do the double exclamation thing. Lastly, if an effect hits a whole area, for example, a fireball, it'd be good to indicate what the area is. In the targeting section, we're going to add something. I think we're going to add... Let's see. Ah, okay, I see what's going on. So in targeting... For mob in map tile, blah, blah, blah. Where's that part at? For mob in map tile. We're going to put the position stuff there. And instead of get mob, it's going to be... Oh, we're not getting the position because we already have the index, right? Yeah, we already have the index. And this is... Yeah, so we don't need the if let. Is this in a loop already for the tiles? No. We'll see how it works. Let me not get wrapped up in something before we even do it. All right, save that. Now, instead of position.x, it's going to be tile idx dot x tile idx dot y. We're going to make it orange. I'm not sure where that tile idx is coming from. That's what I'm curious about. And on the character here, we're going to make... Yeah, I'm not going to figure this one out. This weird thing. Also with 200. So what I see on the tutorial for mob in map.tile content, idx.iter, targets.push star mob. And then we just use tile idx here. Is it not IDX? Where is tile IDX coming from? I see no indication for that. Double check over here. All right, let's see. Area of effect. We're in the right place. Actually, that's... No, that's the problem. We're not in the right place. Got it. Yeah, that's the problem. I should have looked down below. We're in single target. I missed the comment there. We're in single target. We do that here. That's why I was getting confused. Now we have tile index, right? So yeah, what I was getting confused on was basically we do this for every tile in the area, and I was like, that should be in a loop, but it's not. And I kept getting thrown off. That's why I said, let's put it here and then figure out what I'm missing. Yeah, I looked for the code, and I got just like laser focused on that specific piece of code that looked the same. And I was thinking I must be in the right place, but no, I wasn't. So here we go. We put it in a loop here for the area of effect, and this is in the middle of a loop that does this for every tile in the blast radius, basically. And we put that weird staticky symbol thing. Okay. So now, tutorial says that wasn't too hard, was it? If you cargo run, you'll see various visual effects firing. So let's check it out. Expand this so I can see. I really want the fireball, but we'll grab that. Yep, that one's been happening. That one's not really exciting anymore. Here's one. All right, let's watch for a health, for healing. Yep, I turned green for just a moment. Okay. Heal again. No, we'll hold off. If I can get to another floor, I'll get more healing. Yeah, like that. Then I can heal. It's better. Strategy. All right, we have the magic missile and confusion. Fireball, that's what I want. Come on, where are you at? Need someone to fire. Fireball is E. See what it looks like. Boom! That's cool. I like it. Magic missile, does it do anything? I couldn't really tell. Fusion. Boom. The question is very quick. 200 milliseconds is very quick, but yeah, it did stuff. Okay, that's good enough for me right now. All right, so we're gonna do one last thing, it looks like. Adding an indicator for missing a turn due to confusion. Lastly, we'll repeat the confused effect on monsters when it's their turn and they skip due to being confused. This should make it less confusing as to why they stand around. That's confusing. So we'll go to Monster AI system. We'll have to modify it a little bit. And I'm gonna do that the easy way here. Can I just do this? Yeah, if I'm getting all of it, let's just do that. Okay, so we'll go to there. We'll do the impulse system for Monster AI. We'll update that. Okay. We'll have to add something to the use, right? But pretty good spot. Not much needs to change. Impulse system for Monster AI. Boom. We need the particle builder. What did I do wrong? What did I do wrong? Hold on. Alrighty. We'll do it a slower way here. Something's clearly going wrong. That's good. Get the system data here. I think I copied over something that I didn't need to. Still prefer to do this than the other way, than actually reading every line and typing in the breakdown here, just to make sure I got everything. Okay. So at the end of the confusion test, if they're confused, can act false, yeah, then we're going to say particle builder dot request. It's going to be position.x, position.y, RLTK, RGB, named, RLTK, magenta. We need like a shorter way to do that, because the named ones are really annoying to me. And they take up so much room. So then this time it's good. I don't actually have to scroll left and right. They indented, or they took it down to the next line. But usually I do. Alrighty, that's all. We don't need to worry about getting the position because we already get it as part of the loop. So if we cargo run, we'll find a confusion scroll. See if this works. Expand the game so my old man eyes work. That's fire, not confusion. I mean, I'll take it. Really empty dungeon so far. Also, no sign of stairs yet. Is that it? Yeah. All I need to do now is find a Zambambo. Alright, so we're going to get here next to him. We're going to use confusion. Boom. So now if I skip my turn, he's confused. See it? Skip again. Boom. Love it. He starts fighting back now, but that's cool. Alrighty. It's good enough for me. Let's go. We're done with that. We don't need to worry. We already read that. Okay, cool. And there we can see it in action too. You know what? I need to check something else. I've had a hard time reading the tooltip. It still is a little hard to read on that. Never mind. I might check. I might literally just start the next section from a full copy of their code. That way to make sure I'm in complete parity. If any tiny little changes happen, sometimes, you know, you like I missed some diagonal movement for monsters before. I just forgot, like, as I'm typing it, I missed a couple +1s and -1s and stuff. And that's a problem. The behavior's different. And I debugged it, like, well, debugged. I like, looked around and figured out what's going on, but there could be a lot of tiny things like that that are slightly being missed, which it's a pain. Like, what sucks about it is, like, if you're building the game yourself, you drill down and you find these things. If you're following a tutorial, you're like, wait, why doesn't mine behave the way theirs does? Right? And you run, that's where things get weird, because then you're like, well, how many sections are we in? We're so far down this list. How do I figure out why that one little thing, like, where did that little discrepancy happen? Right. So anyway, wrap up. That's it for visual effects for now. We're giving this, we've given the game a much more visceral feel with feedback given for actions. That's a big improvement. It goes a long way to modernizing an ASCII interface. All right, this will be the last one we're gonna do. It's a little bit shorter than the last one actually, but it's gonna be. This is the one I'm most interested in. I really wanted to get this one today. A hunger clock and food. Hunger clocks are a controversial feature of a lot of roguelikes. They can really irritate the player if you're spending all of your time looking for food, but they also drive you forward, so you can't sit around without exploring more. Resting to heal becomes more of a risk-reward system in particular. This chapter will implement a basic hunger clock for the player. Did we do that? Did we make it where waiting heals you? Or was that the other tutorial? Where skipping a turn heals you by 1 point? Or did we not do that in either? I know, like, Caves of Qud does that, but whatever. Maybe we did implement that here and I just forget about it. Adding a hunger clock component. We'll be adding a hunger clock to the player. So the first step is to make a component to represent it. So we're going to add a hunger state enum with 4 states. We're well-fed, normal, hungry, or starving. We're going to add a clock, which is actually just a component with a hunger state and a duration. My guess is going to be some number of turns transitions you between each state. Having not read this, that's my guess just based on the enum and the component there. So we're going to add that. We're going to register it. And then let's see what's going on with this player stuff. This is what I'm most interested in right now, though, because it's the biggest change to the game. So here we are. We have the hunger state and all that fun stuff. Boom. Now to register, hunger state is not a component, right? That's an enum. So we don't actually register it, but we do register the hunger clock, which is a component. So then we need save load system, hunger clock on both of these. We need to bring it in, import it as well. We'll check that later. Something popped up. I was gonna mark it as a watch later, but the notification will still be there. Ooh, that's awkward. Another very weird, awkward notification popped up. Asking me if I want to plan something for somebody who is no longer with us. Alrighty. So as with all components, register in main, save load, and spawner.rs will extend the player function. So it's not, I just assumed it was going to be player.rs, but no spawner.rs. This is where we make the player. Oh, here it is. So I guess it's the last thing we're going to do before marked. Dot with hunger clock. And it's going to be state is probably going to start as well fed, right? And then duration is going to be 20. 20 turns? That's a quick timer. Is it what I hope we do? I don't know yet, but there was a little bit of dialogue at the start of this section that basically said it can be annoying if you're looking for food and stuff. So we're going to need more drops. Like, no, excuse me, we're going to need more items spawning, but maybe also drops. It would be cool if you could, like, eat the corpses of your enemies or something. Actually, that's something you should be able to do. That'd be fun. Add that kind of system, like eating a corpse. You could do some stuff like that in, like, NetHack, for instance. But there are potential issues with that. There's no hunger clock component in place, but it doesn't do anything. So we're going to need a hunger system, which is going to be handled by hungersystem.rs. And it's quite straightforward, but it's a lot of code. So let's start breaking this thing down. We're going to cheat and pull in the use statements here. So we're going to get hunger clock, run state, hunger state, suffer damage, game log, and that's it, yeah. They reordered as I was reading it and it threw me off. So we're gonna need a pub struct hunger system. I'm feeling that hunger system right now. I didn't eat before stream like I normally do. I took a nap. We're gonna allow Flippy type complexity. And we're gonna make a system data. And it's gonna be what? Entities. It's gonna be write storage hunger clock, because we are changing the clock. Read expect entity player. Read expect run state. I guess like if the player starves to death, are we changing the state? No, we're reading the state. I guess that determines whether we change the clock or not. Yeah, that's the guess right now. Suffer damage. I can imagine what that's going to be for. We're going to need to write expect on the game log. Like, bruh, you're starving. Get some food. All right. We're going to be a little bit lazy on this. We're going to get the... Oh, whoops. Okay, there it is. Yeah. We're going to be a little bit lazy on this now and just break apart that system data. So we're getting the entities, the hunger clock, the player entity, the run state, the inflict damage, and the log. Well, that's what we're naming them, rather. Alrighty, then what? For entity, mute clock. Now here's the fun thing, right? We're, hold on, I need some water. We're making this a system for entities with a clock. Ergo, we could put hunger clocks on other things and actually have them act accordingly. They need to eat. They will take damage. You could make this affect their AI behavior if you wanted. If you wanted to have like a living city, right? NPCs would get hungry and they'd have to go find food or something. There's a lot you could do with that. Already, just by putting it here in this loop, that this could make anything in the game that you want get hungry, as long as you give it that component. I like that. So we're gonna say proceed is false, whatever that's gonna mean. We're gonna match on the run state. We only care about two of them. So run state, if I can type, player turn, run state, monster turn, and then we don't care about anything else. Proceed is false. So in this, we're going to say if entity equals player entity, proceed equals true. And then down here, if it's a monster turn, if entity not equal player entity, whoops, we need to star that. Proceed equal true. So monsters can have hunger, basically. That's what we're defining here already. Depending on who's taking the turn, we're deciding how we proceed. That's all for that match. So if proceed, then I gotta scroll down because it keeps going. Clock.duration minus equal 1. If clock.duration less than 1. Okay, so it's literally every turn. 20 turns is not a lot to like just walk around the dungeon to switch your okay, no, okay, it's gonna be better than that. I see. Match clock.state. We're gonna need all of them. We're gonna say well-fed, normal, hungry, starving. Perfect. It actually went in the perfect order. I'm gonna do this. Get rid of the to-dos. All of them start with a clock.state equal hunger state, and we'll just say normal for now. Clock. Make sure that the L is in there. Clock.duration equal 200 if entity equals player entity log.entries.push. You are no longer well fed. To string. And that's that. I need to do that semicolon on all of them. When I clicked out of the window, I lost my multi-line edit. We're gonna have to do a little bit of modification to some of these, but basically the general logic is almost the same. So we go from normal, we go from well-fed to hungry, we go from well-fed to normal, normal to hungry, hungry to starving, and then in the case that we're starving, this one's actually a little bit different. We don't need the clock.state. Inflict damage from hunger. We got the hangry. We're hangry, right? So then here is the really unique one. Suffer damage. New damage. And mute, inflict damage. Entity. Ooh. Entity 1. All right. So we also need to modify the logs. You're no longer well fed. You are hungry. You are starving. Your hunger pangs are getting painful. You suffer 1 health damage. All right, I think that's everything. I could sanity check on that match by copy pasting their match. I'm gonna do that real quick, just as a sanity check. In case I did something slightly off, but basically, pretty easy to break down what's happening. Let's talk about the entire function now, the entire system. Basically, everything is built around a loop on entities with hunger clocks. And depending on what state the game is in, if it's the player taking a turn, then we want to proceed. If it's the monster taking a turn, and it's, well, okay, if it's the player taking a turn and the entity is the player entity, then we want to proceed. If it's the monster taking the turn and the entity is not the player, then we want to proceed, right? So if the monster takes a turn, we want the player to get hungry, right? Only when the player does something. So then if we should proceed, then we take 1 off the clock duration, and if it becomes 0, if it's less than 1, then we match on the clock state. And again, it's like a state machine. We're well fed. If we're well fed, then we go down to normal. If we're normal, we go to hungry. If we're hungry, we go to starving. If we're starving, we take damage. And then we set the clock duration to 200 for each state, except for starving, because we don't go any further than that. And in the case of starving, we do an appropriate log for each case. And in the case of starving, we suffer damage. That's it. Pretty straightforward, actually. And now for the tutorial's description. It works by iterating all entities that have a hunger clock. If they're the player, it only takes effect in the player turn. Likewise, if they're a monster, it only takes place in their turn, in case we want hungry monsters later. The duration of the current state is reduced on each run-through. If it hits 0, it moves 1 state down, or if you're starving, it damages you. Now we need to add it to the list of systems in main.rs. The one problem right now, which we haven't addressed, is that we don't have any way to fulfill that hunger. So there's going to be some more logic to go on here. We're not done, but we can starve ourselves now if we want. So I did this right before the particles spawn. Let mute hunger equal hunger system. Hunger system. You know what? I didn't add that up here, and it worked. I forgot to add it in here, and I was getting syntax highlighting, wasn't I? Huh. I've had problems. Maybe it's because I rebooted the machine so recently. Hunger.run now and self.ecs. So what I mean specifically by that is probably more just on the VS Code side of things, where sometimes it gets bogged down. And rebooting VS Code, restarting VS Code can help, but rebooting the system also plays a role there. That's fine. We're not actually including it here anyway, but mod hunger system, do it anyway for fun. Wait, did I bring it in? Oh, why is it up here? Maybe I did. Am I correct? Did I forget that I did it? Why is it at the top? Doesn't matter, but why is it at the top? It got auto sorted up there now. Weird. All right, whatever, doesn't matter. So we cargo run now and wait a lot, you'll starve to death. Let's do it. That was actually going to be my test. Was starving. Begin new game. No longer well fed. I'm just holding numpad 5 to wait. That was 20 turns. Okay, that was 200 turns. We're hungry. Starving. But the interesting thing is we're not going to die. Because of something we talked about a few minutes ago. Oh, no, there we go. No. Oh, yeah, we're not going to die. Because of what we talked about a few minutes ago. Every time I wait, I heal by 1. So I'm resting to heal, but I also get hit by the same that I'm healing. Like, it's a little goofy. It will kill you if you're walking around, but it doesn't really make sense that you could see it flickering. I'm holding the button. Eventually I should starve to death, but I won't because of that. But if I start walking around, I just bleed. That's a little goofy. All right, we're done. Okay. So there's maybe some cleanup to make that look better, but it works. It's a cool system so far. Displaying the status. It would be nice to know your hunger state. We'll modify draw UI in GUI.rs to show it. Okay, so draw UI, we're going to do a match on the hunger state, all that. Okay, not bad. We're going to pull... Okay, we're going to pull hunger in. We're going to join it. All right, it's not bad. All right, let's get to it. Let's talk of hunger. I need food. I need a quesadilla. Alrighty. Draw UI. Why does their draw UI seem a lot short? Oh, they put dots. That's why they abbreviated it. Okay, I think this is where we really care about. Combat stats, players. We'll get the hunger. Let hunger equal ECS.read storage. And it's going to be hunger clock. Alrighty. And then here on this is going to be players, combat stats, and hunger. And this we're going to call it HC. Hunger clock. Alright. So we get our health. We draw that bar, we draw bar horizontal. And then match HC.state. Hunger. So I'm glad it's ordering it the way I want it to. That's so good. And ctx.print color 71 42 RGB named RLTK green. This one gonna be RGB named RLTK black. Any line that you see like this, you'll notice I pretty much always have to click over and scroll because the RGB names are just too long. Well fed. Now obviously that's not correct for all. So for hungry, it's literally hungry. For starving, it's literally starving. For some reason, we don't put anything for normal. We're actually just going to clip this out. But I thought it was easier to just work on all the lines at once. And then the colors are different as well. So it's going to be green, orange, and red. Okay, there we are. So for cargo run, we get a decent, pleasant little display. Let's check it out. There we are. Bottom right, well fed. And now if I hold the thing there, we get no hunger status there. Now we get hungry. And then we're gonna get 4, 3, 2, 1. Oh, pretty close. 1 second off. And same thing as before. I could walk around until we succumb to the hunger. Alrighty. Cool. So now we have a little problem. The game's gonna end pretty quickly because we don't have anything to eat. Adding in food. It's all well and good starving to death, but players find it frustrating if they always start to die after 620 turns and suffer consequences before that. 620 may sound like a lot, but it's common to use a few hundred moves on a level, and we aren't trying to make food in the primary game focus. We'll introduce a new item, rations. We have most of the components needed for this already, but we need a new one to indicate that an item provides food in component.rs. So we'll make that. And we'll, as always, we'll register it. You know the drill. We've done it multiple times today already. Where is components.rs? There it is. So we need to go to main. What's it called? Provides food. And then you know that also means we got to go to the save load system. Because it would really suck if, like, you saved your game and then you loaded back and food stopped working, right? So you definitely want to make sure that that's saved and loaded. Alrighty. So now we need something in spawner. Where is spawner? There is spawner. And we're going to make just a couple functions that are pretty similar to the ones we already have. So I'm just going to grab tower shield here. And we're going to say rations. That's identical, so it takes a position. Renderable is going to be a %sign. And it's going to be green. And then the name is going to be rations. It's going to have item. It's going to have provides food. Instead of equipable. It is consumable. And simple marker serial. Okay, let me just double check. Position renderable. Name. Oh, it's important to check that render order, but it is correct. But item provides food, consumable, simple marker serialize me. Okay, we're good. We'll add it to the spawn table. Quite common, so it's the last thing, but it doesn't matter the order because the way the weighting works, it's still gonna be fine. Rations, map depth. We're not doing that. We're just gonna say 10. The thing is, though, if you played for like hundreds of levels, the rations would be exceedingly uncommon because of this thing that's like something plus map depth. Or even this, yeah, map depth -1. At some point, you're just basically not going to find anything else. That's fine, though. And the spawn code, we have a match somewhere. Rations, ECS, XY. Alrighty, if we cargo run now, we'll encounter them that we can pick up and drop. How we can, however, eat them. So I'm not going to cargo run. I'm just going to go ahead and head to the inventory system, and the relevant portion. See the tutorial source for the full version. That's fine. We hopefully don't need to do that. So basically, item use system. I don't think it matters too much where we go. So we'll pop down here before used item. Is it edible? Eat it. No, if it is edible, eat it. Let item edible equal provides food dot get use item dot item. Now I think we're gonna get a problem here. Yeah, we're gonna get a problem here. That's fine. Match item edible. None. We don't do anything. Some. We don't actually care about anything in there. Used item equal true. Let target equal targets. 0. Let hunger clock equal hunger clock dot get mute target. If let sum hc equal hc c dot state equal hunger state well fed. Cool. And then hc dot duration 20 game log dot entries dot push format you eat the blank. Oh, this is always a fun one. Names dot name or dot get use item dot item dot unwrap. It's not done, is it? Yeah, dot name. There we go. Now it's mad. We need to get hunger clocks and provides food. And I'm going to do this myself. I'm not going to look at the source because we've been doing this long enough. I think I know what we need to do. So dot get is the key here. That's what we care about. Because what we know is if we have all of the components of a certain type, like provides food, what's the actual name of the component again? Yeah, it is called provides food, or the hunger clock components, or any other kind of component, right? We can then do a dot get to get that specific entity that we pass in, which is what we're doing here. Use item dot item is the entity of the item that's being used, right? So that's what we're saying here. And then target is the actual thing that's eating, right? The thing that the item is targeting. So with that, that should be all we need to know, that what we're doing, we're not joining this. We're actually just going to be needing access to these. So provides food and hunger clocks. Can I copy both of these? How weird is that going to be? Oh, it's going to be bad. Yeah, I'm not going to do it that way. We'll get up here though, and what we'll say is provides food, hunger clocks. And now the other two key things that we need here is read storage, provides food, and then write storage provides hunger clock, excuse me, hunger clock. Now, still have a little bit of red because I typoed duration. Hunger clocks.get mute. Oh, we didn't declare it mutable in the thing here. I did preempt it in one case, but we need to make it mutable here. What we did is write storage gives us write access, mutable access to the hunger clock, but we still have to say mute here if we want to actually get a mutable reference to an entity. So That was going to be the key that I wanted to point out, that because I already know we're modifying the clock, we do need to keep that in mind here, and make sure we're getting the correct thing. If we go to read storage, fat fingering things. If we go to read storage, we should see some red down below and say there is no get mute. The method get mute for the struct doesn't exist. Or it actually does exist, but the trait, it's done via traits. Okay. So write storage does satisfy the trait, but read storage does not, which makes sense. So now if we cargo run, we can run around, find rations, and eat them to reset the hunger clock. We're going to do something else too here in just a minute. Let's do this. Let's find some food. They should be pretty easy to find early on here, given that it's a value of 10. I would like multi-page inventory, though. I like to hoard. You watched me play Cataclysm Dark Days Ahead, which I'm now, I'm done with for now. I played it for a while. I kind of got my fill. I'm still sad the way it ended, but what I was going to say, if you watch me play that, see how much of a hoarder I am. All right, so we're going to wait a little bit. We're hungry. So if we eat rations, we're well fed. That only lasted for 20. Is that all we really did? Hold on. Or was it? Well fed lasting 20 seems too short. So we are now starving. And once those 200 turns run out, we're going to start taking damage. And then like, oh, we're struggling. Oh, we found some rations. We're no longer starving. We're no longer taking damage. Awesome. We can rest to heal up. Boom. Alrighty. We're good, right? Almost done. We're at the very tail end here. Coming in about 2 hours. Not bad. Considering 4 sections here in about 2 hours. That's very respectable. I mean, they've been fairly short. So we're going to add a bonus for being well fed. Be nice if being well fed does something. We'll give you a temporary +1 to your power when you're fed. This encourages the player to eat even though they don't have to, sneakily making it harder to survive on lower levels as food becomes less plentiful. In melee combat system, we add a hunger clock bit. Okay. And that's going to be it. So let's just do that. Very, very tiny bit of code there. Where's that at? It's around the offensive bonus. So here's our offensive bonus. So we'll then go here and say if let sum HC equal HC. Then we'll say if HC.state equal hunger state well fed offensive bonus plus equal 1. Now HC is probably not going to be happy because we haven't pulled that in, so it's actually let HC equal hunger clock dot get entity. Now that's not going to be happy either, because what is hunger clock? Well, same thing as before. Hunger clock. And then that means we need it up here. Boom, that's it. Okay. So now we'll get a bonus for being full of rations. I'd like to demo it. Let's try. We need to find rations and find an enemy, or find an enemy right within the first 20 turns, which both are equally valid. Okay, we found rations, then we're good. Don't really care about anything other than finding an enemy now. I can't, like, I know what rations are, but I can't not think about Metal Gear Solid when I hear ration. Rations, let's go. So I deal 5 damage. Wait until I'm no longer well fed, and now I deal 4 damage. Player hits goblin for 4. So if you were paying attention, we'll do it again before I die. I was hitting for 4, eat some rations, 5 damage. We'll run away. 4 damage. And we see you're no longer well fed and stuff popping up in the logs down there too. Cool. Good stuff. Alrighty. Then, little bug that I mentioned earlier. As another benefit to food, will prevent you from weight healing while hungry or starving. This also balances the healing system we added earlier. So in player.rs, we modify skip turn. And that's the trick, because I mentioned earlier, that's a little bit busted. That's why. Okay, so player.rs, very, very quick fix too. Where do we want to put this? Skip turn. Here it is. So near the top, we'll say let hunger clocks get equal ECS.read storage, and we're going to need the hunger clock. Then let HC equal hunger clocks.get player entity. No, it popped up, then it disappeared. I just went too quickly. All right, so we get that. We do an if let sum HC equal HC match HC.state hunger state hungry and heal equal false. Hunger state spelled hungry. Starving and heal equal false. And then we need the other arm. And this was actually right before something else, so we're gonna move this now. It's right because I didn't read the code to see where it needed to be. It's right before this. Okay. So there we go. And now we have a working hunger clock system. Let's try it. Basically, if I hold the button now, we'll starve to death very quickly. That's the real test, right? But we're gonna... Nah, it's gonna be too fine grained. I was gonna say I could go get damaged. Well, actually, no, I can. Yeah, I don't even heal now. Okay, see, I'm not even healing now. If I'm holding the button, we're stuck at 28 health. But what's gonna happen, we're gonna go starving, we're gonna wait 200 turns, then I'm gonna just die out in 28 turns, because I'll lose 1 health per turn. 3, 2, alright, I was off. Alright, that's it. Cool. Let's head back over to the tutorial where we are done for now. So we just did that skip turn stuff. So then we now have a working hunger clock system. You may want to tweak the durations to suit your taste or skip it completely if it isn't your cup of tea. But it's a mainstay of the genre, so it's good to have it included in the tutorials. Boom! 4 done here in about 2 hours. Not bad at all. Next is magic mapping. You read it and then the whole dungeon is revealed. That's sexy, I like it. Fancier roguelikes have nice graphics for it. Rex paint menu, which is going to get us a cool menu, like a cool main menu maybe or something. Yeah, we did that in the other tutorial where we had a main menu with an image. So that one's going to be pretty short. Magic mapping is going to be medium length. It's not bad. Simple traps is going to be the longest. We're messing with the spawner, I noticed, and I don't even know what all is. Bear traps. Okay, this is going to be crazy. Alrighty. It's going to be a fun time. So that's going to be next time. We're going to try to do all 3 on Wednesday. And then that means next week is finally going to be onto generating maps, which I'm really excited for. We could see here, there's how many? 20 different sections on there. Now, that one doesn't count as a conclusion, probably. But refactor, map building, and then we're going to do test harness and binary space partition room dungeons. So BSP means, as well as interior design, cellular automata maps, drunkard's walk algorithm, mazes and labyrinths, diffusion, limited aggregation maps, all kinds of crazy stuff. Not going to read all those right now. You got eyes there on the screen, but I'm not going to patronize you like that. But it's going to be fun stuff. I'm really excited about that. Not that I'm not excited about the stuff here. I was super excited about the hunger clock, and I actually really liked the way that was implemented. Pretty straightforward, but very effective. You know, I was thinking about, like, how would we do that? I didn't sit there and actually try to reason it out myself, but I just kind of thought about it, you know, passively, like, wonder how that's going to happen. It was interesting to see how that played out. I really liked that implementation. Very simple. And again, what really made me happy about it was how quickly it's implemented for everything now. Monsters, everything. I like that. I think it'd be really cool to add drops from monsters as another way to potentially get like food and stuff. Add multiple food, like food items. Add loot, like drop tables for monsters. Like, I mean, you're getting way more advanced at that point, but it could be fun. All right, so that's going to be it for today, though. I'm going to go ahead and wrap up. I'm hungry. All this talk about the hunger system, I think it's affecting me. Someone turned that system on me. But it's a good one today. Like I said, I mean, a lot done for only a couple hours. I mean, there's been other ones that took like 2 to 3 hours for a single section. So I feel like we made good time today. I am copying a few things, like when we do components now, and some of those system data ones are pretty beefy. So again, rather than go line by line and see what changed, that would be a good idea for the tutorial. Highlighting, like somehow showing, like show the whole thing, but like specify these are the lines that changed when you're adding to something. That'd be a good idea if you're doing a tutorial, because it's actually pretty, it's a little bit overwhelming when you got a system data thing there with like 10 plus different things in it. And I've seen this, and if you pay attention to the tutorial, when I'm doing this, sometimes the orders are different. And it's like, why? It didn't just get stacked on at the end. It changed things around, and it's like, okay, what's different? Why? How? Let's figure this out. Almost like a little diff thing would be nice. Okay, I'm going to get off that tangent, though. I'm going to wrap up. So thank you to anyone who showed up. I really appreciate it. If you like this, you want to see more, hit the follow button. I do these streams every Monday and Wednesday. I'm not going to do my whole game schedule, but every other stream, every other day is gameplay. But Monday and Wednesday are these Rust coding streams. So if you like that, that's when they're going to be happening. If you want to check out some gameplay, that's cool. I appreciate that too. Like I said, every other day. 2 of them on Saturday and Sunday, I will say that. One earlier in the day and one at night. So, other thing, if you're on YouTube, I'd appreciate it if you do all that fun YouTube stuff. Like button, subscribe, notification bell, you know how all that stuff works. Leave a comment. I do try to respond. I actually need one I need to go respond to. We were having a good conversation over there, and I got behind and didn't get around to responding again. So I need to get back on that. We do have some good conversations going on over there so far. Fun times. So yeah, I do read. I do try to respond. That's enough of that. So I think I've covered everything. Already covered what we're going to be doing next time. And then the time after that. And the time after that. And the time after that. Because, well, there's a lot of map stuff. So some of them are probably fairly short. Some of them, I think actually from skimming it, a lot of them are fairly short. Maybe not. No, maybe not. 4-eye hive maps, that's not too bad. Wave function collapse, that's a single, that's a full stream right there. That's beefy. Oh, we're talking about prologue. Y'all haven't touched prologue in almost a decade now. Wow. Oh, wow. That looks crazy. Cool stuff. See, this is what, like, I'm so excited to see this stuff in action when we get there. All right. Enough, enough looking at this cool stuff that's going to be many, many sessions from now, it looks like. That's another long one. Yeah, It's gonna take a while. Okay, we'll try to do like 2 per session as we get to the map stuff. But again, it's gonna be, I'll be like 1 stream, 1 stream, 1 stream. I mean, we're looking at like probably like 15 or so streams based on what I've just seen there. I thought they were gonna be quicker. I think it was maybe something I looked at later on that was pretty quick. All right, that's enough. Again, I'm getting sidetracked. Already done an outro. I don't got anything else to say. So until next time, have a good day, have a good night, whatever it is, wherever you're at. Take it easy.
Oh no,